Hello friends, this is Ramneek Singh. Welcome to the third session of Robotics and Embedded Systems. Today we'll talk about the circuit for buzzer and switches, and then we'll do just a part of the program to start the buzzer using a switch. I hope you remember the motherboard. So this is your buzzer and these are your switches. Today I'm going to explain the circuit for the buzzer. This is the circuit for the buzzer. So what do we have here? This is a resistance. This is a transistor which is N-type and one point of it is grounded. The other point of the transistor is connected to the buzzer and one point is free. That is, it is connected to the pins. So to make the buzzer sound, we have to make some current flow through it. Since one point is grounded, it is having 0. So we need the other point to be at a higher potential. So we need to give it a 1. Therefore, we give it a 1 by making it active high. So this was your buzzer circuit. Now we are back to switches. These are your switches as I told you earlier. And the circuit for the switch is this. As you all can see, one point of each switch is grounded and the other point is connected to the respective pin. So like if we need to activate switch 4, how will we activate it? We need to complete the circuit to activate switch 4. So how do we do it? Since one point is grounded, we can take it as 0. To complete the circuit, we need the switch also to be 0. That is why it is active low. I hope you remember that by active high, I mean that we need to give it a 1. And by active low, I mean that you need to give it a 0. Now let's head back to the program. This is your program and today I'll be explaining you till here. Okay, just have a look at this configuration. As you can see, here it is mentioned that switches are active low and they are connected to port A, pin 4, 5, 6 and 7. And I hope you remember that buzzer is active high and it is connected to port C3. Okay, so now back to program. Like always, we first include the main header file, that is avr/io.h. Well, one thing that I want you all to know is that we are not using the standard C library here. That means standard C header files like iostream or conio will not work here. This header file which you have included right now is made exclusively for robotics purposes. That is why please don't get yourself confused that why aren't we using iostream and why are we using avr/io.h. Next, I declare the main function and inside main I've assigned values to the ports and I've assigned the input or output direction. So now we have seen from the table that switches are connected to port A4, A5, A6 and A7 and we need to reset these ports first. So to reset any port, we need to make it inactive. And since switches are active low, we give them a high, that is 1 to reset them. And for buzzer, we already know that they are active high. So we give them a low, that is 0. So as you can see, port A is 0xF0. Why 0xF0? Since I've explained in my first session that we always number the nibbles in a decreasing order, that is 7 to 0. So this is your first half and this is your second half. Okay, and the switches are connected to pins 4, 5, 6 and 7. That is the first half. And to reset it, I've told you that we need to give it a high, that is 1. So I set it to 1, 1, 1, 1. That is 1, 1, 1, 1, 0, 0, 0, 0. Okay, so what does these 4 1 represent? This represents a F in hexadecimal coding. Okay, and 4 times 0 represents a 0 in hexadecimal coding, and hence port A will be equal to 0xf0. Okay, now port C, as I've earlier told you that it is active high, and to make it inactive or to make it or to reset it, we need to give it a low, that is 0. So we'll be having the code 0 0 0 0 0 0 0 0, that is 8 times 0. So first half also represents a 0 and second half also represents a 0, and thus port C will be equal to 0x00. Now the direction for port A. Since we'll be pressing the switch, that means we are giving it an input, and here I have explained that to give the direction for input we need to give it a 0, and for output we give it a 1. So DDRA will be equal to 0x00. So why 0x00? It's 0x00 because we are giving it an input, and for an input we need to set the pins A4, A5, A6 and A7 to 00. Now for DDRC, I've given the command 0x08. Why 0x08? Since we all know that the buzzer is giving us an output and it is connected to port C pin 3. So we need to give pin 3 a high. A high means we need to set it to 1. So what we'll do now? We'll give the first half 0. We'll give the third bit a 1, the second bit 0, first bit 0 and 0th bit 0. So your first half, that is this one, represents a 0, and the second half, that is 1000. What does it represent? It represents 8. So 08. Friends, this is it for now. Stay tuned for the explanation of the next half of the code, and a timetable for various tutorials will be put up soon on the site. Thank you, friends.